Alright, let's go on to the next one. Now, this page right here, we already did with our activity, but I didn't have you guys fill it out. That's okay, we're going to skip it. We're going to talk about multiplicities. Now, we haven't talked about multiplicities at all yet. So, I'm going to do a little tiny miniature activity with you guys, but you guys got to pay close attention because if you're not paying attention, you're not going to get it. You got to tell your neighbors the answers. Okay, so here, let's go over to our friend Desmos. So in Desmos, we're going to put... let's put, what were those factors I said, let's remember. X plus 1, right? X plus 1. And then the other one was, it was X minus 2? Yeah. X minus 2. Okay, now I know the one that we have on our paper has a negative in front of it, but I'm going to leave it like that. No, we put a fat negative in front of it, remember? Okay, now, multiplicity has to do with how many factors the 0 comes from. I have 2 factors right here. And what are my zeros? Negative 1 and 2. So negative 1 and 2 are my zeros. How many factors does negative 1 come from? There's one factor. X plus 1. That's it. Now, I could put another x plus 1 right here. What happens to my graph? Do I have the same zeros? Yeah. The zeros are exactly the same. Except negative 1 now comes from 2 factors. So what is the multiplicity of negative 1? It is 2. Before it was 1, now it's 2. You guys see the difference? Yeah. Okay. Let me show you guys what it used to look like when it was a multiplicity of 1. Now there's a different way I can write this. See, if I delete this, now it has the multiplicity of 1 again. Okay. I could write it a different way. Instead, what I can do is I can write this with the power of 2. Because isn't that the same? That's the same as x plus 1 times x plus 1, right? So, do you see what happens to the graph? Yeah. Okay, now watch. If I delete the 2 and I make it a 3, what happens? Do my zeros change? No, zeros are still the same. But look at the difference. Let's see. Let's put the 2 back. You see the 2? Mm-hmm. Now I put the 3. Here, make a prediction. What if I put a 4 right there? What's going to happen? Tell your neighbor your prediction. You got to make a prediction right now. Tell your neighbor your prediction. Okay, now watch it happen. I delete. I put a 4. So now the multiplicity is 4. Doesn't that look familiar? Yeah. It looks kind of like the multiplicity of 2. Hey, so I have another challenge for you. Can you predict what's going to happen if I put a 5 right here? What if I make it a multiplicity of 5? Tell your neighbor right now. I put the 5. What happened? Oh. Yeah. Now it's going, the function, when I say it, the function is going through the line now. What? Okay, another prediction. Sorry, guys. I have 3 more predictions to ask of you guys. What if I make this into a 6? What's going to happen? Tell your neighbor. There it is. Now it's a 6. And what's the line doing off of the negative 1? It is going through it. Is it going through the negative 1? No, it's bouncing. It is bouncing. What if okay, let's do a 7. If I put a 7 there, tell your neighbor what's going to happen. Go. If I put a 7 there, what's going to happen? What happened? It is, the function is now going through it. You guys see it? You see that bouncing going through? Yeah. Okay, so, oops, that's the wrong one. Okay, now let's put a even exponent right onto our x plus 1 factor. Now you can see that it's bouncing off the 0 instead of going through. So just to recap, if it's an even multiplicity, then the line's going to bounce off of the 0. And then if we have an odd multiplicity, it's going to go through the 0. Now, there's different ways that a function can go through a 0. The first way is, like, if I had a 0 right there and a 0 right there, it'll go right through just like that. These are multiplicities of 1. But if we have a higher odd multiplicity like 3, 5, or 7, then when it goes through the 0 that has a higher odd multiplicity, it does like a little squiggly, kind of like that. Okay? I always think about like the x squared, or not x squared, but the x cubed graph. Whenever it goes through the 0, it does that. It doesn't go straight through it like that. It kind of does like an S turn.